Okay, so today we're going to be talking about site surveys and the process of performing a site survey. So um, you see below, there's two sites that I'm using as examples. Now, whenever we get a client, we obviously look at their site to make sure that it is a viable spot to build. The site on the right obviously is viable. There's already an array built on it. You can also see there's not a ton of shading around it. Looks pretty good. The site on the left, there's a ton of trees. This place is basically buried in a forest. You're going to have to take out all of these trees, essentially, if you would want to make this a viable site for solar. Um, Now, talking about performing site surveys, there's a few definitions that we're going to go through. Quickly, the first of which is azimuth. This basically refers to the angle that the house is facing, or the degree that the house is facing. Now, ideal direction is south, and the angle of that, of true south, I should say, is 180 degrees. The tilt is just the pitch of the roof. I reference a 45-degree slope. You may hear roofers sometimes talk about a 12-pitch roof. It's 12 inches rise, 12 inches run, that comes up with 40 degrees. TOF, tilt orientation factor. This basically just measures how much sun the roof is going to see based on the tilt and the orientation, so the way it's facing and how much it's tilted. Solar access, this measures how much the sun the roof surface will get based on shading from the surrounding obstructions like trees, chimneys, vent pipes, etc. TSRF, total solar resource fraction. This accounts for the tilt, orientation, and shade. And it's basically calculated by multiplying the solar access and the TOF. It essentially talks about the overall production or viability of that section of the roof or that site. Frequently with some of these pieces of software, it'll break it down per panel so you can see what the TSRF is per panel. Otherwise, sometimes you can see it per entire site. This image that you see to the right is actually something that I shot several years ago while using a SunEye. So one of the older ways that we used to obtain a lot of this information, like the solar access, the tilt, the TSRF, was using this tool called the SunEye. And so what this gentleman is doing right here, he's on the roof, he's kneeling down, he's measuring what is basically going to be the production on that roof right there for that given time. And it gives a good wide range around it. So it kind of helps determine how viable that area is going to be. Now, for a typical roof surface, you want to take several of these shots, and it's going to come up with images like this that kind of show where the sun path is going to be at any time of the year. We've kind of gotten away from using these tools. We've gone more towards using drone photography and satellite imagery to figure out what the shading is going to be at different sites of the roof. Reason for this is it's just a little bit dangerous to have somebody get on the roof like this all the time and crawl around it. I physically did a lot of them. People still do it this way. It's just a little harder and a little more time consuming. So in addition to evaluating the actual shading and system size that the system is going to be, we look heavily at what the roof condition actually is. So this example to your left is a pretty old and beat up looking roof. This would not be a buildable roof. You can kind of see that the shingles are, cracked and fraying. They're starting to cup a little bit further up. You can see they're missing grains. It's not good. Whereas this example right here, this is a brand new roof. That's ideal. It's what you want. It's really not super cost effective to remove a solar system so you can re-roof it. It is doable. It's just something that we like to avoid if we can. So one of the other things, in addition to the quality of the roof, that we're going to have the site surveyors look at while they're on site is the actual framing of the building. So this little simple diagram right here shows a lot of the actual framing of the roof. And it also shows roughly what we're going to have the site surveyor look for. So the length of the rafter, this is frequently obtained from the outside of the building. The run, this can be obtained from the outside of the building, but while you're in the attic, it is a good idea to actually stand right under the ridge beam, if there is a ridge beam, and send your tape measure across so you can actually try to figure out what that distance is. Additionally, if you can't get in or if there's a weird circumstance, you can figure this out mathematically using the tilt of the roof and the length of the horizontal here. Additionally, we do need the surveyors as well to get the dimensions of the rafter and the spacing. So for instance, common framing is like 2x6 is at 16 on center. 2x8, 16 on center, 2x10, so on and so forth. Sometimes it goes up towards 20 inches or 24 inches, and sometimes with older homes you can see some really more sporadic spacing, but more commonly you're going to see either likely 16 inches or 24 inches on center. But this does require us getting in or having our surveyor get inside the building. So when we do schedule these, it does take a little time sometimes to have someone actually get out, be able to physically go and meet the property owner and be allowed into the space in order to get up into the attic to try to determine whatever the rafters are. That pretty much covers what we're looking for with a generic site survey. If you have any other questions, please feel free to reach out to either myself or James, and we'll be happy to help. Thanks so much. I hope you found this video informative.